This is question 26. This question says two particles of mass 6 kg and 24 kg are separated by a certain distance. The ratio of the distance of center of mass from a 6 kg mass and that from a 24 kg mass will be. So, 4 options are 4:1, 2:1, 1:5 or 3:1. Now, dear students, in the question there is a 6 kg mass and there is a 24 kg mass. Let this be the center of mass. Now, let this be distance x1 and let this be the distance x2. We have to find out the ratio of the x1 with respect to x2. Now, if we consider the center of mass to be at origin, we can write down that 6 into minus x1 plus 24 into x2 divided by 6 plus 24 will be equal to the location of center of mass, and here in this case it is equal to 0. On simplification, we get a value of x1 by x2 to be equal to 4 by 1. Therefore, the required ratio is 4:1, and hence for this question the correct answer is option A. Now, let us proceed to the next question. This is question 27. The question says, consider the following two statements. In the forward biased condition, width of the depletion region in a PN junction diode decreases, and the second statement which says barrier potential for PN junction depends on the amount of doping. The correct statements are only A, only B, both A and B, or neither A nor B. Dear students, the forward bias voltage, it is opposite to the barrier voltage, that is, it is opposite to the barrier voltage. This is something that we should remember, and therefore, in this case the depletion width decreases. Now, in the reverse bias, the potential barrier will increase. In the reverse bias, on the similar principles, the potential barrier, dear students, increases. And why so? Because the barrier potential is in the same direction as the reversed bias voltage, and therefore, if we consider these facts, we can find out that both A and B are the correct statements, and hence the answer for this question is option number C. Now, let us proceed to the next question. This is question 28. The question says light of frequency f is incident on a photosensitive surface of threshold frequency f by 2. The energy of the fastest photoelectron is found to be equal to k. If the frequency of the incident radiation is doubled, then the energy of the fastest electron will be. Herein 4 options are here: 3k, 2k, k and k by 2. Now, let us proceed to the solution. Dear students, as per the Einstein's photoelectric equation, h nu, that is the incident energy, when used the incident frequency, will be equal to h nu naught plus k. When nu naught is the threshold frequency, h nu naught is called as the work function. K here is the kinetic energy of the fastest photoelectron. Now, in the case 1, we can write down that h f is equal to h f by 2 plus k, which gives us the value of k to be equal to h f by 2. In the second case, it is given that the frequency is doubled, which means that h into 2f will be equal to h f by 2 plus k dash, where k dash is the kinetic energy of the fastest electron in the second case. And on solving this, we get a value of k dash to be equal to 3 hf by 2. From these two equations, we can clearly see that the k dash has a value which is equal to 3k, and hence the kinetic energy becomes tripled. Therefore, for this question, the correct answer is option A. Now, moving on to the next question. This is question 29. In this question, for a light of wavelength 800 nanometers, the limit of resolution of a telescope is found to be equal to alpha. The limit of resolution for light of wavelength 400 nanometer will be, and there are 4 options: alpha, alpha by 2, 2 alpha and 3 alpha. Dear students, the limit of resolution has a value alpha equal to 1.22 lambda by A, where A is the diameter of the lens and lambda is the wavelength of the light used. Now, it is given that the wavelength reduces from 800 nanometer to 400 nanometer, which means that the wavelength becomes half. We can write down that lambda dash is equal to lambda by 2. Essentially, this means that alpha dash, that is the new limit of resolution, will be equal to alpha by 2, and hence the limit of resolution becomes half of its initial value. Therefore, for this question the correct answer is option B. Now, let us proceed to the next question. This is question 30. Question 30 says a resistance wire having length 1 meter when connected in the left gap of a meter bridge balances a 20 ohm resistance in the right gap at a point which divides the bridge wire in the ratio 1:2. The length of the resistance wire which will have the resistance of 2 ohms is. So, there are 4 options: 2 into 10 raised to power minus 1 meter, 1.5 into 10 raised to power minus 1 meter, 1.5 into 10 raised to power minus 2 meter, or 1 into 10 raised to power minus 2 meters. Dear students, the diagram can be drawn. Herein, this is the resistance wire and it is connected to a 20 ohm resistance. Here there will be a galvanometer which will be connected to a meter bridge wire, and when the null point is achieved, it is given that the ratio of lengths is 1:2. Now, if the resistance here is R, we can write down that R by 20 will also be equal to 1/2. This is from the concepts of meter bridge. We can write down that R will be equal to 10 ohms. Now, dear students, the length of the resistance wire is given as 1 meter. So, for 1 meter the resistance is 10 ohms. We have to find out the length for which the resistance will be 2 ohms. Now, the resistance per unit length of the wire will remain constant. So, we can write down that the resistance per unit length will be 10 by 1, that is 10 ohms by 1 meter. This will be the resistance which is equal to 2 ohms divided by the length, that is L. From this we can write down that L will be equal to 2 by 10, that is 2 into 10 raised to power minus 1 meters, and hence for this question the correct answer is option number A. Now, let us proceed to the next question.